Hello everyone. So today we are conducting our Fundamental of Electrical Engineering assignment. I'm Darshan, another Nilesh Kumar, KIG2001.
My name is Boon Ken, KIG170510, and then I'll be mainly talking about the AC motors.
I'm Khor, KIG100144. I'll be discussing DC motor with you guys.
Okay, so now today we'll be providing you insights of all these various subtopics here. Okay, so first we'll be telling about types of motors used. Next is how do these motors work. Thirdly, the application of these motors in various fields. Next is the functionality and control systems of these motors. These motors I'm talking about is AC and DCs. Next is a brief comparison of AC and DC, of how they function and all those different characteristics. Now I'd like to pass over to my friend to explain a little regarding AC motors.
So for the electric motors we are looking at right now. So electric motors is an electromechanical machine which converts electrical energy into mechanical energy. So there are the AC motors and the DC motors. For AC motors, it takes in alternating current as an input, whereas for DC motor, it takes in the direct current as an input. So first of all, we'll look at the AC motors. So the AC motors is a motors that converts the electrical energy into mechanical energy by using the electromagnetic induction phenomenon, which is then called an AC motor. So this motor is obviously driving by alternating current. So for the AC motors, it consists of a stator and a rotor, which is the two most important parts of the AC motors. The stator is a stationary part of the motor, whereas the rotor is a rotating part of the motor. So for the AC motors general working principle, so we are looking at the fundamental operation of the AC motors, which relies heavily on the principles of magnetism. So this simple AC motors contains a coil of wire and then two fixed magnets surrounding a shaft. So when the AC electric charge is applied to the coil of wire, it becomes an electromagnet, which then will generate a magnetic field. So these magnetic fields, when the magnets interact, the shaft and the coils of wire will begin to rotate, then eventually operating the motor. So for the AC motors, we are looking at how it's being controlled. So first of all, we can use the AC controller, which is a device that used to control the speed of the AC motor. The AC motor will receive power, which is ultimately converted by the AC controller into an adjustable frequency. So this adjustable output will allow the speed of the motor to be precisely controlled. Then next, there's a variable frequency drive, which is a particular kind of adjustable speed drive that is used to control the speed of the AC motor. So this variable frequency drive will control the frequency of the electrical power supplied to the AC motor. So for AC motors, is widely used in a lot of applications, from domestic applications to even industrial applications. In your house, we will see AC motors being found in places like the clocks, power tools, disk drives, washing machine, and even fans. Then for the industrial applications, they can be found in pumps, blowers, compressors, and conveyors. Then next, we will be looking into the types of AC motors available in the market today. So first of all, we will be looking at the linear motor. This is the motor which produces the linear force instead of rotational force. So this motor has unrolled rotor and stator. Such type of motor is used on sliding doors and in actuators. Then we'll be looking at the induction motors. So for induction motors, it's classified on the basis of rotor and also on the basis of phase, and then further classified into squirrel cage and wound type under the basis of rotor, and then single phase and three phase under the basis of phase. So this machine is which will never run at synchronous speed. It's called the induction motor, or sometimes called the asynchronous motor. So this motor uses electromagnetic induction phenomenon when transforming the electrical power into mechanical power. So first of all, we'll be looking at the squirrel cage rotor, which is a type of rotor consisting a squirrel cage. So this squirrel cage rotor will decrease the humming sound of and the magnetic locking of the rotor. Then next is a phase wound rotor, which is also known as a slip ring rotor. And then this motor, and then the motor using this type of rotor is also known as a phase wound rotor. Then next we'll be looking at the single phase induction motor and the three phase induction motor. So the single phase induction motor is the machine which change one phase of AC, alternating current electric power, into mechanical power by electromagnetic induction. Whereas for the three-phase induction motor, it is a motor which converts three phase of alternating AC electric power into mechanical power. So for their working principle, right? So this there are twin pairs of electromagnetic coils which are energized and then energized in turn by the AC power supply. Then the current in each coil does not switch off and on and off abruptly, but rises and falls smoothly in the shape of a sine wave. So this current produces its own magnetic field that tries to oppose the thing that caused it. So and then the interaction between the two fields will cause the rotor to turn. Then as the magnetic field alternates between the coils, it effectively rotates around the motor. And then the rotating magnetic field makes the rotor spin in the same direction and in theory in the same speed as well. So for the synchronous motor, I would like my teammate to explain more about it.
Okay, so I'm back. Now let's talk about synchronous motors. Okay, so opposite of the induction motors which do not work on synchronous speed, synchronous motors work on synchronous speed. Okay, so as you can see, synchronous motors are the motors that run at synchronous speed. The synchronous speed is actually constant, which generates electromotive force. The synchronous motor is used for converting electrical energy to mechanical energy. Now let us have a look at the background. So the speed is actually controlled by three factors. One is the rotation of the magnetic field, second is the frequency, and third is the poles of the motor. So for synchronous motor, it's subdivided into another two motors, which is the reluctance and the hysteresis motor. So hysteresis motor, this is type of synchronous motor which has a uniform air gap and does not involve any form of DC excitation system. The torque in the motor is produced by the hysteresis and eddy current of the motor. For the reluctance motor, its starting process is similar to induction motor, which runs like a synchronous motor and is also known as the reluctance motor. So let us look at the working principle of synchronous motor. We provide three-phase supply to the three-phase stator winding and DC of the rotor winding. Okay, the three-phase stator winding carrying three-phase current. So the three-phase has three different currents and produces magnetic flux. The rotor carrying DC supply also produces a constant flux. At a particular instant of rotor and stator poles, there might be a similar polarity, which is the north and north polarity or the south and south polarity, causing a repulsive force. And the very next instant, there will be a north and south polarity, which will cause an attractive force. So due to the inertia of the rotor, it does not rotate in any direction despite having attractive and repulsive forces. So it will be in a standstill condition. So a synchronous motor is not a self-starting motor due to the repulsion and attraction of the poles. Here we use mechanical means which initially rotates the motor in the same direction as the magnetic field, which is very close to the synchronous speed. So now I'd like to call upon my friend to explain a little on DC motors.
Hi. Basically, a DC motor is working on the principle that when the current carrying conductor is placed in the magnetic field, it experiences the mechanical force. In a practical DC motor, the armature is the current carrying the conductor, and the field provided magnetic field. When the conductor is supplied with a current, it produces its own magnetic flux. And the magnetic flux either adds up to the magnetic flux due to the magnetic winding at one direction, or cancel the magnetic flux due to the field winding. The accumulation of magnetic flux at one direction compared to another exerts a force on the conductor, and therefore it starts rotating. And we actually have three methods to control the DC motor. First is flux control method, second is armature control method, third is voltage control method. After several tests and studies, we figure out that the voltage control current is the best method because flux control method can affect commutation, whereas the armature control method involves huge power loss due to the usage of resistor in the series with the armature. And the application actually we are having three types of motor. First is shunt, series, and cumulative compound. And for the shunt, right, it's normally and not majorly used in mechanical tools, centrifugal pumps, blowers and fans. And the series, right, since it has a variable speed, adjustable varying speed, and high starting torque, so it's normally used as electrical locomotive, rapid transit system, trolleys, cars, cranes, and conveyors. And for the last cumulative compounds, right, since it has variable speed, adjustable varying speed, and a very high starting torque, so it's normally used as elevator, conveyor, and heavy panels. And there are two types of DC motor. First is self-excited, second is separate excited. And self-excited motor actually differentiate into three parts, which is shunt motor, series motor, compound wound motor. And for the separate excited, right, actually the motor is which the DC winding is excited by separate DC source, which known as the separate excited DC motor. And we are having two types of shunt motor. First is short, and second is long one. And this is the DC shunt motor, and the short one is only parallel to the armature and the motor, and not the series field. And for the shunt, long shunt, right, the both armature and the series field is parallel to the shunt field winding. And my friend will explain the difference between AC motor and DC motor.
So now let us look at the differences between AC and DC motors. So here we have already listed down the characteristics that differentiates both AC and DC motor. First is the nature of input current. For AC motor, it works on AC direct alternating current, while for DC motor, it works on direct current. So for the supply source, for AC, we can either have a single phase or three phase of supply, while for DC is from batteries and cells, which is only not considered as one phase, but it's a direct source. So for the commutation process, it is only present in DC motors and absent in AC motors. So for the supply phase, as you can see, both single phase and three phase supply are used for AC, while for DC only a single phase is used, as I've said earlier. So for the number of terminals, for AC motors you can have up to 3 terminals because of the 3 phase current, and for DC motors you have 2 terminals, which is the negative and positive of battery. So for carbon brushes, this is rather important. For DC motors you have carbon brushes between the armature, while for AC motors they are absent. Looking at the applications as explained by my friends, for AC motors they are used in large industrial applications, while for DC motors they are used in small domestic house applications. So for the starting, as I said, for the synchronous motor, AC motors are not self-starting, it requires external starting equipment, while for DC motor is a self-starting. Looking at the position of armature, the armature is stationary and the magnetic field rotates for AC motor, while for DC motor the armature rotates and the magnetic field is stationary. So it's rather opposite. Lastly, the maintenance cost. For AC motors they are less expensive, while for DC motors they are more expensive than the AC motors. This is because of only providing single phase, which makes it more expensive. Okay, with that, we'd like to conclude our presentation, and we hope you have learned quite a little from our presentation regarding AC and DC motors. Thank you very much.